Hello everyone, my name is Jessie Holt, and this is my presentation on STEAM, an acronym often used in education these days. So I'm going to be going over what it is, why we should be using it, who should be using it, and how we can incorporate it into the classroom. So, what is STEAM? STEAM in education is when one or more STEM fields combine with art in the classroom. So STEM plus art equals STEAM. STEAM itself stands for science, technology, engineering, art and design, and mathematics. STEAM research is producing an ever-growing body of evidence supporting the connection between STEM and art in learning. Here are some examples. The links to these examples can be found in the small white box at the bottom of this page. I thoroughly encourage you to follow the links and read the articles for yourself. They are very enlightening and rather exciting as an educator. So, example number 1. An article published by Michigan State University found a positive correlation between the number of STEM patents produced by STEM-employed individuals and the amount of exposure they had to all forms of art leading up to the age of 14. Example number 2. A study found in the STEAM Journal, a website that houses STEAM studies and other research, which I highly recommend that you look at. They release journals every so often, but they really are just a great free source for finding research that looks into the connection between STEM and the arts. So this study, done by R. Long and S. Davis, discusses research looking at the connection between literacy, engagement, and the incorporation of art into STEM. The results argue that the interdisciplinary nature of STEAM promotes more understanding, innovation, and exploration than when the disciplines are isolated. Example number 3 was another study that was found at the STEAM Journal, and so once again I highly recommend you check out the website. This study was done by J. Rock and A. Flatt, and it looks at how STEAM versus STEM relates to brain function. And this study makes the case for STEAM as a more dynamic and productive topic for the brain as opposed to STEM alone. So who should be teaching STEAM? Well, when it comes to STEAM in the classroom, science, math, and art classes can all benefit, and thus the teachers in these classrooms should all know about and incorporate STEAM. So how do we do that? What does STEAM success look like, and how does one go about incorporating STEAM into the classroom? Well, one good example is an article from The Art of Education by Tracy Hare, which discusses some of the difficulties one might face in trying to effectively add STEAM to their curriculum. It's a useful read, especially in addition to the following tips. So the following are a set of tips for incorporating STEAM and making sure both the STEM fields and the arts are represented and learned about in STEAM class activities. When writing a STEAM-based lesson, make sure you have a clear set of concepts from 1 to 2 of the STEM categories in addition to artistic concepts. This goes for learning objectives as well. If you are an art teacher unfamiliar with scientific concepts, or vice versa, collaborate with the teacher of the unfamiliar subject at your school. Projects that involve collaboration with different subjects can be exciting and educationally rewarding for students. Some of my most memorable projects from middle and high school were such collaborations, and they were always so enjoyable because they included different types of activities, and so they were able to keep my focus as a student. And I suspect that that is what is going on for students being studied in STEAM research as well. So another tip, avoiding letting either art or STEM outshine the other in a project is crucial. STEAM is all about engaging both subjects with equal import because, for example, creativity is an equally important skill to critical thinking, especially today in our technology and innovation-driven world. It is also easiest to make lessons out of concepts that are obviously complementary. They should inform each other. For example, Pattern is an artistic concept that directly relates to the mathematic concept of fractals, so the two could combine into a potent STEAM lesson. Successful use of STEAM looks like a mutually beneficial collaboration. Students are motivated to explore both types of concepts and how they relate. Ideally, they will reach a point where the concepts are no longer distinguished by their discipline, but rather are all seen as part of the same topic, the topic being learned about in the lesson. Well, thank you for listening to and watching my presentation on STEAM and education, and I hope you have a good day. Thank you.